Why do array starts at index 0? It is not random. It is all about how computer access memory. So breaking down this problem into steps, let's go for this step. Arrays are stored in continuous memory. An array store element next to each other in memory like a row of boxes. Imagine an integer array, int array of size 5, having elements 10, 20, 30, 40, 50. So in the first step, you are seeing the arrays created. Elements are stored in continuous manner. And now moving forward, the first element is located at base address. This is the second step. The first element start at the base address, so its offset from the beginning is 0. The CPU can calculate the address of any element using address equal to base address plus index into element size. So in the second step, you are saying the element at 0th index have offset value 0 and element at last index, that is 4, have the offset value 4. But the base address for the first one is 1000 and for the last it is changes with the element size. So we have 4 bytes for integer, so for last we have 1016 for the last and 1000 for the first. How the CPU calculates an address? The CPU uses a simple formula to find address of any element. Address equal to base address plus index into element size. Here, we are searching for integer which contains 4 bytes. For any particular element, let's suppose at element 3, base address plus 3 into 4, that comes to 1012 because base address is 1000 and we are searching for third element and the size of the index element size is 4. That's why we come to 10,012. Directly jump to the fourth element, that is 40. What if array started at 1? If indexing started at 1, the formula would be address equal to base address plus index minus 1 into element size. So at array of 1 we get 1000, means the offset value for the second is equals to 1000. It still works, but now we need extra subtraction in every axis. Modern compilers are optimized this, so it is not true that one based indexing would necessarily make programs slow. The bigger reason is that zero based indexing fits naturally with memory offsets and pointer arithmetic. The first element has natural offset of 0, works perfectly with memory offsets and pointer arithmetic. Fewer operations required in most cases. Became the standard through C and was adopted by many other languages. This is the fifth step. Now in the sixth, it is not slower than one based indexing. Modern compilers, as I already mentioned about it. The real reason for zero-based indexing is simplicity, consistency, and compatibility across languages and systems. Now the seventh step. This idea is used in many languages: C, C++, Java, JavaScript, Python. Same idea, same convention, a global standard. Eighth step. The simple way to remember: index equal to distance from the first element. The first element is 0 position away, so the array of 0 is equal to the first element, and the array of n minus 1 equals to the last element. So next time someone asks why does programming start counting from 0, you can say because an array index represents an offset from the beginning and the first element has an offset of 0.